Welcome to Enots Engineering, I'm Alan. In this video we take a look at some of the projects we've made over the year of 2018. I'd like to take this opportunity to thank you for your support by watching and subscribing to the videos and wish you all a happy and prosperous new year. So sit back, see how many projects you can remember, and if you've missed some of the projects, they're all on the Enots Engineering channel. There you can see the finish on the bore. It doesn't need a deep hole, it's just to mark the centre. I need to put a 6mm dowel in there which will fit in the hole there, and that'll fit about there, so it can swivel with the degrees each side. Machine this radius on here and put the 0 position there with that mark, so this will match up with the angle on the table. On this end exactly the same as the other end. There's the block. And that fits through now, you can rotate it. And here's the finished indexing ring. This is the feed screw, has a feed of about 5mm. This is the indexing ring with the 12 positions, and this is the indexing lock. So the way this works is you select which position you want and tighten the screw. You don't need to tighten it tight. And on this side you can wind the feed in, and if you notice on this side the indexing screw travels along the slot that you made in the block, but it won't turn. The feed. Move the table backwards and forwards. Turn it a bit more. I don't know whether you can see there the cutting edge. With a little addition to this, I can use this in the tool post, so I can put stock in the collet, machine, square, triangle, hexagon, whatever you need to machine on the end, or drill a hole through the centre of a bar. Also you can use this in your drilling machine, fits in the vise, there's a little indexing fixture. using is the reamer now in a tap wrench, and I'm just turning it around to go through, just to true it back up to 8mm. In the end there I've put a 5mm cap head. You could put a grub screw and it grips the dial indicator okay. The good thing about doing it this way, if you just use the cap head straight onto your dial indicator, you end up damaging the bush on the end of the dial indicator, and then this stops moving. From some scrap steel we've made the dial indicator holder that fits in the tool post. And that's two faces done, that face, that face. I've got this face to do, cut that angle on there. That fits in there. On top of the tripod. So the diamond fits into the holder with this little screw, and the holder runs along the edge of the work rest to keep the diamond parallel to the wheel. And then the rod goes in the back, and the adjusting knob goes in the back of that. The idea is, as I dress the wheel, I can push the diamond out. So I'll start there. The label should give you the manufacturer's name, the type of machine the wheel can be fitted to, the date, the size, the type of material the wheel's made out of, the maximum speed of the wheel in meters per second or revs per minute. Now we come on to the flanges. The wheel's mounted to the bench grinder using the flanges. When you've machined it, when you've got this length correct, it will eject just by turning the tailstock backwards. There, it's just ejecting itself. We'll now machine the front part on the CNC machine with the 3mm peg going into the backing board. And that's it, one eagle finished for the front of a model engine. Here are the tools that you get in the kit. I'll just run through them. The first three tools I've used, and I'll put some of the clips of the video in. They're all 10mm by 10mm shanks. All these tools come with one insert, but most of them have got two cutting edges, and the thread turning tools have got 3 cutting edges. I've just filed the sharp edges off. There's the 3 flats I've just put on. And the idea of that is that the chuck will fit on there, and once the jaws grip the flats, it's not going to turn and twist on the shaft. That's ready to try. Then you can move this in and out easy enough by pushing your drill in and out. Push your drill up to the part. And the inner bar with the chuck on, just rotate. You can use obviously in reverse. Index round to the second position. So I'll put my spanner back on, put the pins back in, there's the spanner, 4 pins, square in the top to fit a standard 1/2 inch socket. We've made 3 of the 4 parts to complete the job. We'll finish this off in part 2. It's already got the wrong centre in there, that's for a male. So you take the cover off the end, turn it round to the pointed part, put the cover back on, and then that's spring loaded, so as I tap the thread and the thread goes in, the plunger will come out, and you can always wind this in a bit further if you need more tension. Now I need to reduce the thickness by 1 mm, so I fitted it in a 4-jaw chuck and I'm facing off the part. Now after taking off some of the sharp edges, that slides in there. So the idea is that this could come off. The spherical washer fits on there. This spherical goes into it. So I can get much closer to the chuck, and I can still tighten this with a socket and a wrench. So as you grind off the face of the centre, it will automatically adjust. You can go right up to the point. There's the finished point, ground right to the end. At least now it's smooth. Now all remains is to put it back together. So one refurbished revolving centre. Without having to change the dial indicator, and check the run out on the inside of the bore. Okay, I've done the taper. They hadn't gone deep enough on the hole here. I've just machined that deeper. What was happening, this was hitting the end of the slot and still wobbling about at this end like that. Now I've machined a bit more out the back. It's gone in further. It's gone up about another quarter of an inch. They'd just machined up to here. Because this diameter is bigger, so it's only the outside edge that I'm using. As long as the outside edge is clear and flat, this goes on the top. The dial indicator fits onto that. Lock that up. Put the dial indicator on with the 0 at 0. Move the clamp on just slightly so you can still lift the tool. Wind the tool up, and as soon as the tool touches the lip of the face, it will move the dial in. So it's just moving there. Here I've reduced the diameter because as you get closer to the finished size, you need the end will start appearing in here. As you can see, it's got a diameter there and it's got a flat there, so you could end up with the diameter hitting the flat. So I've reduced the diameter. I'll just have to take some off the outside of this washer. Still a throw up. I think that's just starting to go on. I've just pulled it out in the collet a little bit so I can part it off to 20mm from the face that I've just machined to the edge. And I'm using a piece of steel with a centre drill hole in the end to protect the point. And this is just a steel bush that's bigger than the bore is bigger than the shaft, so I know the shaft will go through, and it's locating on the outside of the bearing. So I can tighten that in. Tighten up. So now the 3 bearings are in. I've made 2 more centres. One centre that's a little larger than the first one, and the second centre which is made with a steel ball. That should fit just on there. So now when my hand's on the wheel here, any swarf will hit the back of this drop down onto the tray, tighten the cap head up, and that should pull the bush in. Because I've added the bush here, I've had to flatten off the back. The roll pin will still fit in the slot, and you can see the bush is just coming out. So now I've got a steel thread in there instead of aluminium, so I should be able to put more clamping pressure on. Well, that's the aluminium block finished. In part 2 we'll start making the clamping screw and see how it works. Then insert the clamping bolt into the stop. Turn the compound slide in until the tool touches the part. And if you've set it correctly, the compound slide should be on your 0 mark. You don't have to worry about the settings on the dial. You just wind it until it hits a stop and you know the depth is correct. Put your feed on for the next cut. Cut along. When you get to the end, wind out, switch off your lathe, reverse it, wind back into the stop, put your next cut on. So the reason why I made a gap under the bush is so that when you clamp your movable jaws, you can go right under there with the clamp as long as it's not fouling the bearing. These screws are 6mm button head screws, and they're about 15mm long. And if you want to change, if these are sticking out too far, all you need to do is undo the jaw, turn it round, and it puts the bearing then in the centre, so you can either have them on the outside or in the centre of the. Once you've gone round, feed the cutter into the depth you require and complete the second cycle. The idea of these handles is that I can put the nylon handle on there. Once it's tightened down, I can turn the end of this handle, which turns the stepper motor and the shaft. Each one of those little white marks is an LED, and I think there are 176 LEDs in this lamp unit, and I'm using 2 of those. Well, there's a difference in the light quality, and of course you're saving on electricity used. This was made in the 70s. I'm surprised there's not more swarf and dirt inside. You can see we've got some swarf down here where it would collect, but most of the gears fairly clean. I've just sprayed that with some brake and clutch cleaner and it's come up quite clean. But what I do want to do is remove some of the parts and give them a proper clean. Take away the hand wheel first. The hand wheel's held in with this small circlip. These are circlip pliers. Take the circlip out. Pull through when I undo this grub screw on this side. Well, I've fitted it all back together, so the next thing is to look at the top slides, fit the saddle back on. Okay, there's the underside of the cross slide, the saddle. That should be finished. So there's the finished item fitted on the camera. And normally I have this aluminium block on there with this screw through. It's not a scrap camera. I'm going to send it away to get it repaired because I always thought that the screwing part there was aluminium on a die-cast frame, but no, it's plastic. My previous camera, it was aluminium. Okay, I finished the tapping and I've screwed the bolts in to hold the chuck to the back plate. Well, that's another job done, and we'll see how that performs. The cap still fits on there. That's finished, so now we'll change the chuck for the 3-jaw and start to make the handle. I've just machined an angle on this just so it blends in better with the body. So now just turn it round. All I need to do on this end is take the sharp edges off, just form a dome on the end. The jaw on first, and the handle. And the cam works like that. The end of the bar, and it just stops the cam part coming off. And you could use that principle on a small vise. So the next thing to take off is the adjustments. Slacken that screw off, one on the opposite side. This is the bottom part of the tailstock. On the back of the display you have your 2 inputs, or 3 if you bought the 3-axis one. So I'll plug the cable in there, and it has 2 screws to hold it in position, and switch on the power. It does a checks through its system, then displays the results. You've got X, Y, and you might have Z if you buy the 3-axis one. This is an information box, that's just telling me that subdatum number 1 is here. You can 0 X and Y any position. If I want to put 150mm in X, press X, 1, 5, enter, and it will start at 150mm. And that's moved 6 inches, and it's showing less than half a thou. You have got adjustment on the holes. At the hole on the end, this one is elongated, they're all like that, and the way I fix this is through a hole in the end that way. You can see I can still use the clamp, that's not interfering with the clamp. That's the cross slide scale fitted. I'll take that out. And if I look under the cross slide, you see there are 2 holes there. Both of these holes are threaded. Put it in tight, and on the end I've stuck a piece of felt so that this gives some protection to the metal against metal. When I bring the tailstock in, it hits the stop. Well, that's the tailstock stop. Thanks for watching this year's review. I hope you remembered most of them, and we'll see you next time on Enots Engineering.